And again, Brother Richard, can I ask you to pray for us?
Our Father and our God, we thank you for this evening. We ask that you would just be with each student who is in this class, that we may be able to continue to grow in our class, that we may be able to complete every assignment, that we would be able to do well on our tests, and that we complete this and cross this finish line with passing grade. Father God, we thank you for our professor as he pours out his spirit and his knowledge to us. Help us to be able to glean from it and absorb it as he gives it to us. In Jesus' name, amen.
Amen, amen. We are coming to the end of the course. We have, after this session, we have only two other class, and the class will be over, so no more worry about math.
Yes, I was saying, this is one of three classes that I have to do to finish
Yes.
with my BAPS, and so I I don't want to get lackadaisical because I've been going for a while, and I just trying to keep the pressure on me,
Yeah.
keep it
Just
on
take
me.
one day at a time, 1 week at a time, and you will do good. You're coming to the end, so don't worry.
Yes.
Let me go to the share screen and just take a look at uh, no, not this one. Okay, let's take a look at our syllabus. So tonight we will cover algebra, chapter 6 and 7, and how to use formula to solve problem. And your assignments for this week, by Sunday, again, assignments 7 and 8. And then Nichols, chapter 6, the reading summary, and quiz number 3 by Sunday. And I also hope that you will have a wonderful Thanksgiving.
Yes, thank you. You also.
Right. And so let's go to our PowerPoint right here. And let me go to the larger screen. Okay, so our focus are mainly on algebra, and then a little bit later on drawing graphs. And we'll talk about equation and inequalities. Algebra is a generalized form of arithmetic which uses letters of alphabet called variable to represent numbers, and a symbol that represents a specific quantity, and a symbol that doesn't change is called a constant. So we have variable, usually x, and then we have constant, like a specific number, like a number 3. Then we have something which is called algebraic expression, or simply expression. When we have a collection of these variables and numbers and parentheses and operation between them. And again, if there are two algebraic expressions joined by equal sign, there's the equal sign between them, then we have an equation. And when we find a solution to an equation, we say we solve that equation. To evaluate an expression means to find the value of that expression, the value of that variable for the given equation, for the given value of the variable. Let's, for example, take a look at page 309, the examples that are there. My classes. And we go to page 309. If you look at the page 309, at the top of the page, example number 1, it tells you evaluate 7 plus 5 times parentheses x minus 3, x minus 4 to power of 3 for x being 6. So what it means when it says evaluate, it means put that number for x in that algebraic expression and find what's the solution. So we have 7 plus 5, x minus 4 to power of 3. Instead of x, we put 6, as the textbook tells us. So we have 7 plus 5 times parentheses, that 6, which is in the red letter, red ink, minus 4 to power of 3. 6 minus 4 is 2. So we have 7 plus 5 times 2 to power of 3. 2 to power of 3 is 8. So we have 7 plus 5 times 8, which is 40. And then we add them, we get 47. So you always start with the inner parentheses and work outward. You work inside with the inner parentheses, you work outward, then you do the exponential expression, then you do multiplication, subtraction, division, whatever the equation is asking you to do, and multiplication, division, and then you do addition and subtraction from left to right.
Okay, so Professor, you say start with the parentheses, whatever's in the parentheses.
Yeah.
Okay, and then I need to find, so I add 7 times 5.
No. It's
I
7
mean 7 plus 5, excuse me, 7 plus 5. And then I need to find out what is equal to 7 plus 5. So that would be
No. Wait. You start from inside the parentheses.
Okay.
What do you have? What do you see inside that parenthesis?
X and minus 4.
Okay. And what is x?
X is supposed to be a 6.
Okay. So you have 6 minus 4. 6 minus 4 is what? 2.
2.
So you did the inside the parentheses. The next step is do the exponent. 2 to power of 3. What is 2 to power of 3?
Is 8.
8. So that's why you have that 8.
So,
and then you do the multiplication. Before multiplication and division come before you do addition or subtraction.
okay, so when 2 to the power of 4, I mean 2 to the power of 3 means that I add that one number that's in the parentheses, that 2, plus 3 more 2s.
No, you
come up with the 8.
You multiply 2 3 times. Hi, Ruben.
Hello.
Hi. You multiply 2 3 times. 2 to power of 3 means 2 times 2 times 2.
Oh.
So you get 2 times 2, 4, 4 times 2, 8. That's where we get the 8. Okay, so you work from inside the parentheses. We are on page 309, example 1, if you want to follow us. You work from inside the parentheses. First, you find out what is x minus 4. X is 6, so 6 minus 4 is 2. Then when you're done with the inside the parentheses, you go to the exponent. 2 to power of 3 is 8. That's where you get that 8. 2 to power of 3 means 2 times 2 times 2. The power of 3 means you multiply that number 3 times.
Okay.
Then you do the multiplication. Multiplication and division come first before you do any addition or subtraction from, and you do that from left to right. So you multiply 5 times 8, you get 40. Then you add 40 plus 7, you get 47.
Okay, so after I multiply the 2 times 2 times 2, then I multiply the 5
That's right.
times 8.
That's right. That's
So it
right.
multiplied twice in a row.
Yeah. Well, actually, yeah, the first two times the first 2 times 2 times 2 is exponent. Exponent is an exponential expression. So you do the parentheses, then exponential expression, then multiplication or division if you have division.
Okay. Uh-huh. Okay. Okay.
All right.
Yes.
Let's look at example number 2. It says it gives us it says evaluate x to power of 2 plus 5x minus 3 for x being equal to minus 6. Now here x is minus 6. So we substitute for x, we substitute minus 6. So we have minus 6 to power of 2 plus 5 times minus 6 minus 3. You see that?
Okay. So since there's no parentheses there,
So we just have to do the exponent.
okay.
So you first find what is minus 6 to power of 2. Minus 6 to power of 2 means minus 6 times minus 6, which becomes plus 36. Okay?
So then you
Okay. Do you get the 36?
You multiply the 6 times
you
6.
raise it to power. You raise it to power of 2, which means to multiply it twice.
Mm-hmm.
Then you come to the next parenthesis, you multiply 5 times minus 6. You get minus 30. Okay? So you have 36 plus parenthesis minus 30 and then minus 3. 36 plus minus 30 is equal to 6. And 6 minus 3 is 3.
Okay.
You follow? Let's look at example number 3. Now, it becomes a little bit more, it's not difficult, but just a little bit more complex. It's evaluating algebraic expression when you have 2 variables. Now we have x and y, and the expression that we have is minus 2x to power of 2 plus 5xy minus y to power of 3. It says evaluate that for x equal to 4 and y equal to minus 2. So what do you do first? For anywhere you see x, you substitute 4. Anywhere you see y, you substitute minus 2. So you get minus 2 times 4 to power of 2 plus 5 times 4 times parenthesis minus 2 minus parenthesis minus 2 to power of 3. Okay, I've done all the textbook has done here. We just substitute the number for x and y. All right. Then you go and you start first, take care of the exponent. Minus 2 to power of 3 means minus 2 times 3 times itself. Minus 2 times minus 2 becomes plus 4. Plus 4 times minus 2 becomes minus 8. Then we have another exponent, 4 to power of 2. 4 to power of 2 is 16. So I have 2 times 16 plus 5 times 4 parentheses minus 2 minus 8. Okay? Then the next level, you have minus 2 times 16 is minus 32. 5 times 4 is 20. 20 times minus 2 is minus 40. And we have minus 8. So minus 32 plus minus 40 becomes minus 72. Then minus 72 minus 8 minus that minus times the negative by 8 becomes plus. So you have minus 72 plus 8. So the final answer is minus 64. You follow?
Can you go over that one more time?
Okay. So on example number 3, we have two variables. We have two variables, x and y.
Yes.
And x is 4 and y is minus 2. So anywhere you see x, put 4. Anywhere you see y, put minus 2. So you get minus 2 times x to the power of 2 means 4 to the power of 2 plus 5 times xy. X is 4, y is minus 2. We put, because it's minus, we put that inside the parentheses. Minus, then parentheses, minus 2 to the power of 3. I first take care of the exponent. Minus 2 to the power of 3 is minus 2 times itself 3 times, which becomes minus 8. Because minus times minus is plus, plus times minus is minus. 4 to the power of 2 is 16. Then we do other multiplication. 2 times 16 is 32. The sign is negative. And 5 times 4 is 20. 20 times minus 20 is minus 40. So you have minus 32 plus minus 14 minus 8. When you add minus 32 plus minus 40, you get minus 72. And then when you subtract that from minus 8, you see that minus makes the sign for 8 plus. So you get minus 72 plus 8, which is equal to 72, minus 72 plus 8, which is equal to 64. You see that in those red ink by the side of the expression, the author has tried to explain everything.
Yeah.
Okay?
I see.
Okay, let's continue. When, in algebraic expression, we have what is called terms. For example, if we have expression 7x minus 9y minus 3, the terms that you have are 7x minus 9y and minus 3, which you can write it in another form as 7x plus parentheses 9y and plus minus 3. You haven't changed anything. Those 7x, 9y, and 3 are the terms with their sign. Don't forget their sign. The number that you see next to the letters are called coefficient. For example, in 7x, 7 is a coefficient, x is a variable. Okay? The coefficient of 1 or minus 1 are usually not written. And minus 3 is called a constant. Okay? Again, these are some vocabulary. The parts of each term that are multiplied are called the factors. The factors of the term 7x are 7 and x. You're multiplying 7 by x. You have like terms. For example, if the variables are the same, they are called like terms, especially if they have the same exponent. For example, 7x and 3x are like terms. You can add them up you get 10x. And we have also a distributive property of real number that enables us to combine like terms. Like if you go to page 3112, it tells you the properties of the real number if a plus b is the same as b plus a. If you have algebraic expression 13x to the power of 2 plus 7x is the same as 7x plus 13x to the power of 2. You can change their position. It doesn't make any change. You have the commutative property of multiplication. AB is the same as BA. X times 6 is the same as 6 times X. You have associative property, means A plus B parentheses plus C is the same as A plus B plus C. 3 plus parentheses 8 plus X is the same as 3 plus 8 plus X, which equals to 11X. And you have the associative property of multiplication. We can multiply by both sides. ABC is the same as whether you multiply A times B first and then times C, or you multiply B times C and then multiply by A. And distributive property, if I have A parentheses B plus C, that's the same as AB plus AC. If I have 5 parentheses 3x plus 7, that's same as 5 times 3x becomes 15x, plus 7, which becomes plus 7 times 5, which becomes 35. This will help us tremendously in solving algebraic expression. And when we say we simplify the algebraic expression is when parentheses have been removed and like terms have been combined. For example, let's look at page 314 and 315. Okay, let me do this on my tablet. For example, on page 315, let's do number 41. Let me first get the tablet. So I have to change the stop sharing. Okay, here. All right. Okay, so we are on page 315. I am looking at the exercise number 41. Okay, so it says 7x plus 10x. It says simplify this algebraic expression. These are similar terms. The variables are the same, the exponent are the same. I just can add that. That's equal to 17x.
X, okay.
Okay, let's do that. Another one, which is a little bit more complicated. Let's do number 62. Number 62, it says 7x minus 4. Then we have these brackets, 6 minus 8 minus 5x, parentheses close, and then bracket. It says simplify that. So I start from here. I start from inside and move outside. 8. So what I do is I can multiply this negative inside. So I get 6 minus 8. Minus times minus become plus. I get 5x. Okay, you follow me?
No.
All right.
You
So
went into the You went into the parentheses.
Well,
And
I went inside the parentheses. There was no exponent, so I took this minus, which is -1 actually. I multiplied the inside the parentheses by that -1. So I get -8 and -5x.
Mhm.
So I have 6 -8 plus 5x. 6 minus 8 becomes -2 plus 5x. Okay? And I have -4 here also. All right? So now I multiply this -4 inside this whole bracket. So I get -4 times -2, I get -8. -4 times +5, I get -20x. All right? You follow me?
Okay.
So I have, this is what I have right now. Here. I have 7x -8 and -20x. So these are like terms. 7x and -20x becomes -13x -8. So that's the final result. -13x -8.
I have one question.
Sure.
On the one right there, on the second to the bottom where it says 7x -4, and then you have the parentheses 6 -8. Um, since it's -4, um, I'm sorry, the last one. Since it's -4 times -2, wouldn't it be +8?
Oh, yeah. Yeah, you're, no, wait a minute. No, okay, no. Okay, but before you multiply, you have to subtract 6 minus 8.
Right,
So,
6 -8, which gives
yeah, you're you're right. Let me see, where am I? So this should be actually plus
+8, right?
Yeah, you're right.
Okay, I
So
was
this,
just
yeah. Sorry about that. So let me correct that. This should be +8.
it's just 13 -13x +8.
Yeah,
Okay.
that's it. Yeah. Okay, do you follow me? Richard, are you okay?
Okay, I just I seen where how he Ruben had that corrected the because both minus means a positive.
Yeah.
Okay.
All right. Good. So let's go back to our PowerPoint. Okay. Yeah, okay. All right. And to solve linear equation, a linear equation is an equation that the exponent is 1 and it's expressed as ax plus b equal to 0 when a is not 0. Um, to solve that, we used again the properties of addition and multiplication. And for example, let's look at page 318. Page 318 tells us the properties of addition and properties of multiplication. If a is equal to b, if I add the same number to both sides, is the same. A plus c is equal to b plus c. Or if a is equal to b, if I multiply both sides by the same number, I haven't changed the equation. On the table 6.1, for example, if the equation is x minus 3 plus a, to solve it means to find the value of x. So what you do, you add plus 3. You want to have x on one side just by itself. So you add plus 3 on both sides. So then plus 3 minus 3, they cancel out. And plus 3 plus 8 is 11. So you get x is equal to 11. Or if you have x plus 7, the second one, x plus 7 is equal minus 15. I want to have only x on one side. So I subtract minus 7 from both sides. Minus 7 plus 7, they cancel each other out. Minus 7 and minus 15 become minus 22. So the answer is x is equal to 22. Let's look at the last one. X over 5 equal to 9. So I multiply both sides by 5. And the 5 in the numerator cancels out with the 5 in the denominator. And 5 times 9 is 45. So the answer is 45. You see that?
So that 45 would go on the top of the 5.
Well, yeah, it stays in the numerator because it didn't have any denominator. So you multiply both sides by 5. 9 times 5 is 45. All right? Okay, let's continue. Solving linear equation. Simplify the algebraic expression on each side by removing grouping symbols or combining like terms. Collect all the variable terms on one side and all the constant numerical terms on the other side. Isolate the variable and solve it, and check your solution. For example, let's look at page 328. Let's look at page 328. Let's look at example 11 first. If you look at example 11, it says solve 4x plus 6 equal to 6 times parentheses x plus 1 minus 2x. Okay, so what do you do? First, you simplify, meaning you multiply that 6 inside the parentheses. So you get 4x plus 6 is equal to 6x plus 6 minus 2x. Then you do grouping. 4x plus 6 is the same as 6x and minus 2x are the similar variable. You combine them. 6x minus 2x is the same as 4x. So you get 4x plus 6 equal to 4x plus 6. So if you can see actually basically the answer is 6 is equal to 6, which is true, no matter what the value of x. All right, let's look at number 14 on the exercise at the bottom of the page. Maybe I need to do with my tablet. Okay. No. Okay. So we have on number 14 at the bottom of that page, we have 3x, oops, 3x plus 8 equal to 50. Okay, so when it says solve it, you want to find the value of x that makes this equality true. So what you do, you get rid of all, you put all the numerical value in one side and the variable on the other side. On one side, you separate them. They have to be on two different sides. So what I do is I add -8 to both sides. So here, -8 cancels out with this one. So we get 3x is equal to 42. All right?
Mm.
And then I divide both sides by 3. Here, x cancels with that one. So I get x is equal 42 divided by 3, which is equal to, I believe, 14. You see what I did?
Yeah.
Yeah, so you want to have your variable on one side, the numerical value on the other side, then you simplify it, you find the value of x. So that means for x equal to 14, that algebraic expression holds. All right? Oops. Let's continue.
Professor, how
Yeah.
did you come up with the 8 to put on both sides?
Oh, okay. You see, I looked at 3x plus 8. I want to get rid of that 8.
Yes.
Okay, so if I have +8 on one side, how do I get rid of it? I subtract -8. But I have to do it to the both sides,
Both
in order
sides.
not to change the value. You can
Okay.
do that. You can add or subtract the same value from both sides. That will not change the value of your equation
You're either going to add the same number or subtract the same number
to the both side.
to both sides. Yes.
Yeah. So
Okay.
that's where I get the -8.
Okay. Yes, I got you. Yes.
Okay. So let's move on. All right. Okay. You can also do cross product, meaning if A is over B is equal to C over D, it's the same as AD times BC. You multiply A times B is times B times C. It's the same as this. For B not equal to 0 and D not equal to 0. The cross product AD and BC are also equal. That's another property. Let's, for example, if you look at page 325, you look at page 325, you have example number 7. It says 63 over x equal to 7 over 5. So the cross product property tells me that 63, if I take 63 multiplied by 5, it's the same as taking 7 times x. When I do that, I get 315 is equal to 7x. I divide both sides by 7, x is 45. That's the answer. A over B is equal to C over D. AD is the same as BC. That's what they did. They did the cross product principle. They took the numerator of the first fraction multiplied by the denominator of the second. That's equal to the numerator of the second fraction times the denominator of the first fraction. All right? You see that?
Mhm.
Shall I continue?
Yes. Yes.
Okay. Or let's look at page 329. On page 329, for example, look at exercise number 64. You have minus 3 over 8 is equal to 6 over x. Maybe again, it's easier to show it with my tablets. Okay, so I got minus 3 over 8 minus 3 over 8 equal to 6 over x. So cross product property means if I multiply this by this and this by this, they are equal. It means minus 3 times x is equals 6 times 8. 6 times 8 is 48. And I have minus 3x here. I divide both sides by minus 3 to get rid of that minus 3. So these two cancels. So I get x is equal to minus 16.
45. Oh,
16.
16.
Okay.
I'm lost right there.
Wait.
I thought, okay, after the 3 canceled out the 3.
The 3 canceled out. So you get x equal to 48 divided by minus 3.
Okay.
48 divided by minus 3 is equal to 16.
Okay. Then it goes to dividing.
Yeah.
Not multiplication. How do you know the transition between multiplication?
I mean, because you want to
You just look
simplify.
at it.
You have if I have 48 divided by it's a fraction minus 3. To simplify that, you have so you have 348 that goes one time,
And it
and
goes.
then 18 that goes 6 times.
Yeah. Okay.
And because you have the negative sign, so that becomes negative.
Negative. Okay. I got it. Yes. I seen it now. Okay.
All right. If you multiply it, then you have to multiply the other side, and again you get the minus 3x on the other side. We don't want to do that. We want to simplify. We want to have only x on one side.
Yes. Okay.
Okay.
Yes.
All right. Let's go to the other one. Okay. Oh, sorry about that. Oh, okay. Now we have to also learn how to translate algebraic translation based upon English phrases. Page 332 gives you a very good sample. If we go to page 332, you can review that for yourself. Things such as sum of a number and 7 means to add x plus 7. 5 more than a number plus 5 means x plus 5. If you have a number minus 4 means x minus 4. 9 fewer than a number means x minus 9. When you have multiplication, it's like when we have 75% of a number, it means you take 0.75 times x. Division is the same way, and sometimes you can have more than one operation. Review that table 6.2, algebraic translation of English phrases, to learn how, this is important, to how to do word problems. To do the word problems, as you see on the top of the page, says read first the problem very carefully to find out what's the variable, what is unknown. Then write the expression for any other unknown in that problem. Then write an equation in an X that models the verbal condition of the problem. Solve the equation and check your answer. The best way is to look at one example. Example on page 333. You know, these are basically the same thing I just told you. You know, read the problem carefully. If possible, draw a sketch to help to visualize the problem. Find out which quantity what's an unknown quantity, what are you looking for, and choose a letter for it. Usually choose X. Then write that word problem, which was in English, write it in algebraic expression. Solve the equation. When you get the answer, put it back to check your answer. For example, this on page 333. Example 1 on page 333 says the graph in figure 6.4 shows the average yearly earning in the United States by highest educational attainment. All right, and this was what year? I don't know. Anyway, it tells you, you know, depending on what your degree, what's your average salary. It says the average yearly salary of a man with an associate degree exceed that of a man with some college degree by 3,000. You see here, it says that if a person has an associate degree, that person on average earns $3,000 more than a person that has only some college degree. And the average yearly salary of a man with a bachelor degree or more exceeds that a man with some college degree by 41,000. Now, if you combine the three men with each of these educational attainment, the total on average is 188,000. Now, as you find the average yearly salary of a man with each of these levels of education. Okay, so we want to find the average yearly salary of man with these different educational background. We call that X. Let's start with the first one. The average yearly salary of man who has some college degree in $1,000. It doesn't tell us exactly what that is, but it tells us that a person who has an associate degree gets $3,000 more. So X plus 3, so X is a person who has some college degree, some college education. X plus 3 is a person who has an associate degree. Where did I get that? Tell me. Where did I get, or the textbook, where did I get X plus 3?
On the graph, right? The graph is showing you that it's.
Well, yeah, actually, from the word problem, it tells you if X.
Oh, some colleges by 3,000. It says on there.
So if X is person with some college, X plus 3 is person with the associate degree.
Gotcha. Yeah.
Okay. And then it says if a person has a bachelor degree, that person gets $40,000 more from a person with some college degree. So the third person is X plus 41. You see that? Now it tells me if you add all three of these persons with their educational background, their total average income yearly is 188,000. So here now I can write my algebraic expression. x plus 3 plus x plus 41 is equal 188. And these are in $1,000 units. Okay, now I can solve that. So I do all the addition. I get 3x plus 44 is 188. I subtract 44 from each side, and then I divide it by 3. I get x is equal to 48,000. So a person with some college degree gets $48,000 a year. A person with an associate degree gets $3,000 more, $51,000 a year. And a person with a bachelor degree or more gets $40,000 more, he gets $89,000. You see that? You follow me?
Yeah, I see it.
Okay. So you read the problem carefully. Then you ask yourself, what are we are trying to find out? Well, actually, the problem tells you average yearly salary for men for each of these levels of education. You start with the least one. It says the average yearly salary of a man with some college degree is X. If you get an associate degree, you get $3,000 more, so you get X plus 3. If you have a bachelor degree or more, you get $41,000 more. So it's X plus 41. And it tells us that when you add all of them together, you get $188,000. Now you can write your algebraic expression and solve for X. Okay? We can also look at example 4 on page 336. It says, page 336, example 4. It says your local computer store is having a terrific sale on a digital camera. After 40% price reduction, that tells you it has to be a subtraction. You purchase a digital camera for $276. What was the camera price before the reduction, before the sale? So the X is the original price of the camera before any kind of sale. It tells us with a 40% reduction, meaning minus 0.4x, the price is 276. So you have x minus 0.4x equal to 276. And then x minus 0.4x is 0.6x. You divide both sides by 0.6. X is equal to 276 divided by 0.6. X is equal to $460. So the original price was $460. In order to check it, find what's the 40% of $460. It's 184. Subtract that from 460, you get 276, which the problem tells us is the price of the camera after the sale. Okay. Shall I continue?
Yes.
Okay, good. Or let's see, 337, that's the same thing. I mean, on example 5, on page 337, it says, solve the problem P is equal to 2I plus 2W for, I don't know if it's L, I think it's 2L. So when it says solve for L, you want to have L in one side and everything else on the other side. So you subtract minus 2W from both sides. The 2W's cancels out, so you get P minus 2W is equal to 2L. Then you want to get rid of that 2. So you divide both sides by 2. You get L is equal P minus 2W over 2. That's basically the answer. Or here. Yeah. Yeah, if you have more than one variable, that's the way you solve the problem. On example, on page 338, for example, it gives you the total price of an article purchased on a monthly deferred payment plan is described by the following formula. T is equal to D plus PM. In this formula, T is the total price, D is the down payment, and P is a monthly payment. So when it asks you solve it and solve this, first you isolate PM on one side. You want to know the monthly payment. So you subtract minus 2 from both sides. You get T minus D is equal to PM. Then you divide both sides by M. So P is equal to T minus D over M. So it doesn't matter number of variables. When it tells you to solve it for P or T or M, you just want to isolate that variable on one side and everything else on the other side. Linear equalities in one variable, when we have inequality and their exponent is 1, solving an inequality is the process of finding the set of numbers that makes that inequality statement true. These numbers are called solutions, and we say they satisfy the inequality. The set of all solutions is called the solution set of the inequality. And you can even graph it. Let's go to page 342. And 343. For example, you see on the table 6.3 on page 342, it says we have that set builder notation, a set of x for all x which is less than a. If you want to draw the graph, you see on the line we have point A, but notice the circle is not solid because it doesn't say equal to A, it says less than A. Any number less than A. If it says less than or equal, then that little circle becomes solid. If it says all x greater than B, so then you have B, you have the little circle and not solid, and then all the way B goes all the way to the right side. If it says equal to B, then you make that little circle solid. If it says set of x between greater than A and less than B, you have that line in between, and the two circles are empty because it doesn't say equal. Let's look at example 1 on page 343. It says graph each set A, set of x for x less than value of 3. So on the number line, you go to point to number 3, but you don't make it solid because it says less than x. So from there, and then you highlight all the way to the left from 3 all the way to infinity, negative infinity. If it says for all the x greater than and equal to -1, so you start from -1, but you have to make the circle solid because it says greater and equal. And if it says the third equation set, x between greater than -1, but less than or equal to 3, so you have it goes from -1 to +3, but it includes 3, so the 3 is solid, but -1, it doesn't include -1, so it's in an empty shape, empty circle. Okay? Good.
Okay.
So let's move on. We already did that. Again, the procedure for solving linear inequality is the same as procedure for solving linear equation, with one important exception. When we multiply or divide both sides of the inequality by a negative number, we have to reverse the direction of inequality. We are changing the sense of inequality. Okay, let's look at page 344. Example number 2. You see, that's an inequality. So solve a linear inequality. The reason it's called linear is because the variable has exponent 1. So now we will get later on to when we have more than one exponent can be 2. But we have 4x minus 7 greater than or equal to 5. We want to find value of x that makes that inequality true. So just think of it as equality. You can, again, add and subtract. So I add +7 to both sides. -7 and +7 on the left side will cancel out. So I get 4x greater than equal to 5 plus 7 is equal to 12. So 4x greater than equal to 12. We simplify it. We divide both sides by 4. So for all x greater than and equal to 3, that inequality holds. And on a number line, that's how you draw it. You have a solid circle on 3 because it's equal to 3 and goes all the way to infinity. But if you multiply it by a negative, you reverse the direction. For example, on page 345, look at example number 3. Actually, look at B. Look at example A. Is 1 over 3 times x is less than 5. In order to solve it for x, you multiply both sides by 3. Well, you get x is less for all x less than or equal less than 15. This inequality holds. Okay. Now, for the second one, now notice this one. -3x less than 21. I divide both sides by -3, but because I'm dividing by a negative number, I have to change the direction of inequalities. So instead of less than 21, becomes greater than 21. The 2 minus 3 cancels out. You get x greater than -7. So it tells you for all x greater than -7, that inequality holds. And when you draw it on the number line, that's what you see. You have a blank circle for -7, and it goes toward the right side. It goes all the way to infinity. All right? Let's look at page 346. Example 5. Solving a linear inequality and graph it. We have here 2 times x parentheses x minus 3 plus 5x less than or equal to 8 times x minus 1. Okay, so we start by first multiplying those numbers inside the parentheses. We simplify the parentheses. We don't have any exponent. So 2 times it multiplies by inside the parentheses. it becomes 2x minus 6 plus 5x is less than or equal x minus 8. I want to have all my x on one side and all the other numbers on the other side. Okay? So I get, I subtract, let's see.
Professor, which one are you working on right now?
On page 346, example number 5.
Okay. Yes.
Okay, so I want to have all my x on one side. So I subtract both sides. I subtract minus x on both sides. So I move that minus x from the other side and move it to the left side. So I get 7x minus x is minus x. Minus 6 is less than or equal to minus 8. Then I want to get rid of that minus 6 on the left-hand side. So I add plus 6 to the both side. I get minus x is less than or equal to minus 2. All right? But I wanted to have it in positive number. So I have to multiply both sides by a negative. When I do that, I have to change the direction of the inequality. For all x greater than or equal to 2, that inequality holds. And on the number line, you see you get, because it says greater than or equal to 2, you have 2 solid circle. It goes all the way to infinity. Okay? All right, you're following me?
So on that one where it says you subtracted 8 from minus 8x, and that's why the minus 8 comes down to the next one.
Yeah, we have 7x minus 6. So 7x minus x becomes minus x.
That's right. Minus 6, and then on the other side you have just minus 8.
Yeah. But when you get rid of the 6, then we get minus x is less than or equal to minus 2. We want to have it in a x in positive x, so I have to multiply both sides by a negative. When I do that, I have to change the direction of inequality.
Gotcha.
All right. Now let's look at, for example, a little bit more complicated, solving a three-part inequality on page 347. If we have, it says solve and graph the solution for this inequality. Minus 3 less than 2x plus 1 less than equal or less than or equal to 3. So again, what you do, you want to have only x in the middle. So I subtract minus 1 from all the three parts. I get minus 3 minus 1, 2x plus 1 minus 1, and 3 minus 1. It gives me minus 4 is less than 2x, less than or equal to 2. Then as I said, I just want to have x. So I have to divide every part by 2. I get minus 2 less than x less than or equal to 1. And that's the answer. For all x between greater than minus 2 and less than or equal to 1, that inequality holds. And that's how you draw it on the number line. All right? Any question? Are you guys following me? Okay, good. So let's continue. Okay, this is page. Let's see what's on page 348. It's the same thing. Same as what we talked about right now. All right. Now we come to what is called, all the way so far, we talked about linear equations. Now we can have, which means the exponent, the highest exponent is 1. Now we can have exponent 2. And in order, that's called quadratic equation. And usually, in order to solve or factor to make it into multiplying to binomial using FOIL, FOIL method. FOIL means you multiply, if I have parentheses, A plus B times C plus D, F stand for first. You multiply the first variable in each parenthesis, A times C, then O stands for the outer one, A times D, then the inner one, B times C, and then the last, B times D. Basically, you have to multiply A times C and A times D plus B times C plus B times D to get to keep that equation correctly. Oops. A binomial is a simplified algebraic expression that contains two terms in which each exponent that appears on a variable is a whole number. Like, let's look at page 351. And usually when we do an example, that's much more better. Example 1, it says, multiply x plus 3 times parentheses x plus 4. So you, again, F, the first terms, x times x, you get x2. O, the outside terms, x times 4. Then the inside terms, 3 times x. The last terms, 3 times 4, 12. So when you do that, your answer is actually basically is x2 plus 4x plus 3x plus 12. 4x plus 3x becomes 7x. So the combined term, the answer is x to the power of 2 plus 7x plus 12. So the FOIL method, first, you do the terms that are first in each parenthesis. O, then you multiply the terms that are outside, AX times D. Then I, the inside, the B times CX, and L, the last terms, B times D. Okay? Another example, you can see example number 2. It says 3x plus 4 parentheses times 5x minus 3. Multiply F, the first one, 3x by 5x. You get 15x2. Then O, the outer thing, 3x times minus 3, you get 9x. Then inner, plus 4 times 5x, you get 20x. Then the last, plus 4 times minus 3, you get minus 12. When we combine the like terms, you get the answer is 15x2 plus 11x minus 12. All right?
Can you go over that one more time?
Sure.
Yes.
You see, you have two parentheses, 3x plus 4, 5x minus 3. FOIL
Yes.
means the first terms, then the outer terms, the inner terms, and the last term. The first terms in each parenthesis are 3x and 5x. I multiply them, I get 15x2. The outer term, outside terms, are 3x and minus 3. So I multiply 3x by minus 3, I get minus 9x. Then inside terms are 4 and 5x. I multiply them, I get 20x. Then the last terms in each parenthesis is 4 and minus 3. I multiply them, I get minus 12. I get 15x2 plus 11x minus 12. All right?
Yes.
When we want to factor expressions such as trinomials, which is x2 plus bx plus c, so you write two parentheses. You see that on the bottom of page 352. So you have two parentheses, and you have x2. It tells you that you need to have x as the first term in each of them. Then basically, you see, this is very simple. You want two numbers that if you multiply them, you get +8, and if you add them, you get +6. So, well, if I multiply -4, wait a minute. If I do that, if I multiply, if I have two, yeah, well, actually, two numbers, 4 and 2, you multiply them, you get 8, you add them, you get 6. So the whole thing is x plus 2 times x plus 4. Do you see what I did? When you have that expression, x2 plus 6x plus 8, that 8 tells me that you want a number, the second term, that when you multiply them, you get 8. The 6 tells me when you add them, you want to get 6. +8 and +6. Well, 2 times 4 is 8. 2 plus 4 is 6. These are your two numbers.
So in the first one, it'll be 2 times 3 to make 6. That'll go in the first parentheses, and then the 2 times 4 in the second.
Yeah, not 2 times 3. We don't have any 3. You have 2 and 4. You add 2 plus 4, you get 6.
Oh, to add 2 plus 4. Okay. Yes, okay. And
Right.
then multiply 2 times 4 to get 8.
Yeah.
Okay.
Good.
Is that the procedure pretty much all the time?
Well,
You
okay.
switch.
Sometimes if there is a coefficient by x, then you have to go through that FOIL method. If you don't have a coefficient by x, it is just simply, just remember, the last number has to be the product. The coefficient to the middle number should be addition. The last number here is 8. So I have to look for all the numbers that when I multiply, I get 8. It can be 4 times 2. It can be 8 times 1. But when I add them, it must become 6. So it's only 4 and 2. But that holds if the coefficient for x is 1. When it's different, then you got through that FOIL method and finding what are those numbers. Okay. But maybe I think we have an example. I'll show you. So basically, this is FOIL method. A plus B times C plus D. So you multiply A by the first A times C, then A times D, then the inner B times C, and the last B times D. If there is the coefficient of A is 1, then you got it, it's simple. But if it's not 1, then you have to go through this method to find those two numbers. A trinomial is simplified algebraic expression that contains 3 terms. That's why it's called trinomial, in which all the variables have a whole number exponent. Factoring an algebraic expression containing the sum or difference of terms means finding an equivalent expression that is a product. For example, if I have x, if I have that term minus parentheses x plus 3 times x plus 4, so you get x times x. You see, you get the first x times x is x to the power of 2, okay? But I have this negative, so it becomes negative x to the power of 2. X times 4 is plus 4x, but I have this negative, so it becomes minus 4x. 3 times x is 3x, but because of the negative, it becomes minus 3x. And 3 times 4 is 12, but because of negative, it becomes minus 12. So this is a factored form. This is a FOIL form. All right. Which here you can simplify. It becomes minus 4x minus 3x becomes minus 7x. But you have a negative. But when you see again, this is what you get. This is a trinomial form. All right. Which here, if you again notice, if this number is a product of 3 times 4, and this is an addition of 3 plus 4. Just because if we have a negative number, I have to factor that out. But 3 times 4 is 12, 3 plus 4 is 7. Okay, you follow me? I'll continue.
Yes.
You guys okay? Robin, are you okay?
Yes, I'm following along.
All right. So strategy for factoring x2 plus bx plus c. Oops. Let's go to page 352. Actually, we did that. Yeah, we did that already. Oops. So let's go to page 354. Look at page 354. Okay, that's, Richard, this is a good example. Factoring a trinomial when we have 3 terms, but notice the coefficient of x to power of 2 is not 1, it's 3. So that makes it different. Here I cannot just say two numbers that multiply become 28 and add become 20. I have to use the FOIL method. I know I need to have 2 parentheses, so I have, and I know I need to have a 3x because I got 3x2. So I need to have 3x and 1x in the other parentheses. Now, what are the 2 numbers? When you use the FOIL method, it tells you that you said the FOIL method, first of all, it says the product of the first one, the product of the 3x. If I use, if we have 3x2 minus 2x plus 28. The product of the first terms would be if I have 3x times the first terms, 3x times x becomes, wait a minute. Sum of outside and inside product. Oh, okay, sum of the outside and inside product. So the outside product is 3x times 28 becomes minus 28, it becomes 84x. And inside is minus 1 times x. So you get 85x. You see, what it's doing, in order to solve this problem, you have to find the sum of outside and inside product should be equal to minus 20x. The sum of outside and inside should be 20x. For all the options, when you look at on the first column, when you do that, different, 28 can be 1 times 28, can be 28 times 1, can be 2 times 14, 14 times 2, 4 times 7. We're changing the number. The only option is the fourth one from the top to the bottom, because it says the sum of the first terms minus 3x, the sum of the outside terms, 3x times minus 2 is 6x, and the inside is minus 14 times x. you get minus 20x. Only that one gives me that minus 20x. So I figured out that the answer should be 3x minus 14 times x minus 2. You follow me? Do you see what the textbook is doing? You have a trinomial, which means it has 3 parts. But the coefficient of your exponent, the x to the power of 2, is not 1. So that changes the solution. You cannot just say, we want 2 numbers that multiply, become 28, add them, become 20. When you have this kind of situation, you have to look at all the possibilities of when you multiply the outside and inside terms and add them together should be equal to that middle term, minus 20x. For the 28, what are the multiplication of 28? 28 can be 1 times 28, minus 1 both, or minus 28 times 1, or minus 2 times 14, or minus 14 times 2. That's the only one that when you multiply the outside terms and multiply the inside terms and add them together, it gives you the 20x, that middle term. So that's your factor. You follow me?
Yeah.
So remember that, okay? Or look at example 6 on page 355. It gives you, you have a trinomial 8y2 minus 10y minus 3. Okay, again, I know I need to have 2 parentheses, and I know, I can have, I want factoring that when I multiply the outside term and the inside term and add them together, I want to get that middle term. I want to get that 10y. The only option that gives me is that 1, 2, 3, 4, 5. The fifth one from the top is 4y plus 1 times 2y minus 3. Because when you multiply the outside terms, you get 4y times minus 3, 12y, and the inside term, you get 1 times 2y, 2 becomes 2y, and you add them, you get minus 10y. That's the only one that gives you that middle term. You guys following?
Yes.
Okay, good. So this is basically called the quadratic equation, expressed as a times x to the power of 2, b times x plus c equal to 0. When a and b and c are real numbers and a is not 0. So again, let's look at 356. Again, if it's, for example, when it tells you solve x minus 5 times x minus 2 equal to 0, your solution is very simple. All you have to do is asking you for what value of x this inequality is true. It makes x minus 5 times x minus 2 equal to 0. So what you have to do, make each part equal to 0. X minus 5 equal to 0 or x minus 2 equal to 0. You got to do for both of them. For x minus 5 equal to 0, x is 5. For x minus 2 equal to 0, x is 2. So these are your answer, 5 and 2. Or look at example number 8 at the bottom of that page, 356. You have the quadratic equation x to the power of 2 minus 2x equal to 35. To solve that, bring that 35 to the other side. So it becomes equal to 0. You subtract minus 35 from both sides. So you get x to the power of 2 minus 2x minus 35 equal to 0. So now you factor it. So here we are, it's good. We're lucky. The coefficient of x2 is 1. So you're looking for two numbers. When you multiply them, you get minus 35. When you add them, you get minus 2. Well, 35, it's simple, 7 times 5. But which one should be negative? The bigger one, minus 7. So it should be x minus 7 times x plus 5. You follow what I did, or what the textbook did? You brought 35 to the other side, then you factor it. You want, because the coefficient of x2, x to the power of 2 is 1, it makes it much simpler. You want two numbers that when you multiply, you get minus 35. When you add them, you get minus 2. So it should be 7 and 5, but which one should be negative? Which one should be plus? The 7, the bigger one. Because when I add minus 7 plus 5, I get minus 2. Once I get that two parentheses, the rest is very simple. Make x minus 7 equal to 0 and x plus 5 equal to 0. And you get x7 and x minus 5 are your two answers.
Thank you.
Look at page 357, example number 9. It tells you have, again, quadratic equation 5x2 minus 33x plus 40. Now here, it's a little bit makes it more difficult because the coefficient of x to the power of 2 is not 1. So I know I need to have two parentheses. And again, I need to have 5x and 1x. I realize that. But then I need to go through that. Remember, the product of the outer element and the product plus the inner element should become minus 33. There are only two options that gives you that. And that is 8 and 5. So you get minus 8 minus 5, and then you can make those two parentheses equal to 0. 5x minus 8 equal to 0 means 5x is equal to 8. We divide both sides by 5. And x minus 5 equal to 0 means x is 5. For these are your answer. All right? Now, there is also what is called the quadratic formula, which makes the job much, much easier. This is called the quadratic formula. Try to memorize it. It helps you. Basically, it says if you have a equation on the good thing about, the powerful thing about this the formula is this: it doesn't matter that the coefficient of x2 is 1 or not 1. You can always solve for x by using that formula. If I have ax to the power of 2 plus bx plus c equal to 0, the quadratic formula tells me x is, this is the value of x, minus b plus and minus the square root of b to the power of 2 times minus 4ac divided by 2a. So you just plug in the numbers and you get the value of x. That helps a lot, because then you don't have to worry about factoring and what's the factoring, what are the two numbers or whatever. Let's look at page 358, example number 10. You see it says you have this quadratic formula 2x2 plus 9x minus 5 equal to 0. It tells you use the quadratic solution and find x. So you have that formula. You just plug in the numbers for a, b, and c. when you plug in the numbers, you get -9 plus and minus the square root of 9 to the power of 2 minus 4 times 2 minus 5 divided by 4 divided by 2 times 2. And when you start from under the square root sign, you get 81 plus 4 times 8, 4 times 2 is 8, 8 times 5 is 40, and the sign should be plus. 81 plus 40 is 121. The square root of 121 is 11. So your answer is, one of the answers is -9 plus 11 divided by 4. The other one is -9 plus 11 divided by 4. So your two answers are 1/2 and -5. That's the answer. All right. Oh, well, I think it's a good part now to take 5 minutes break because we go to graph and function. So let's take 5 minutes break and then we come back. Any questions so far?
When we come back, can you go over that sequence again?
Oh, sure. Well, yeah, let's do it right now
Okay.
when it's fresh in our mind. You see, it gives you the quadratic formula, and it gives you the quadratic equation, and then it tells you use the quadratic formula, which is right there, x minus b plus and minus square root of b to the power of 2 minus 4ac divided by 2a. You see, remember, all you have to do is to recognize what are a, b, and c. A is the coefficient of x to the power of 2. B is the coefficient of x, which is 9, and c is -5. You just plug in those numbers.
Okay.
Plug the numbers, you start from under the square root sign. You have 9 to the power of 2 becomes 81. A times c becomes 10, -10 times -4 becomes +40. You add 81 plus 40 becomes 121. The square root of 121 is 11. So you have -9 plus and minus based upon our equation, 11 divided by 4. So you do one time -9 plus 11, another time -9 minus 11. All right?
You do it two different ways.
What you have to do, when it's the quadratic, when it says it's power of 2, means there are two solutions. So you got to find two answers. That's why you have plus and minus.
Okay.
That's why you get one answer is 1/2, one answer is -5. For both of these answers, you put them in that equation, you get 0. So it is true. These are valid answers, in other words. Okay?
Yeah.
All right, so let's take 5 minutes break and then come back. Oh.
Ready. Okay. Is that Isaiah? Oh, okay. No. I was just wondering, I heard John.
Going back outside?
No. I'm finna go back on class.
Oh, you are?
Yeah.
Oh, I thought you were done.
No, we just got a break. 10 minutes.
Let me get my water and my. Or I was going walking and with a towel wrapped around it. I said, I don't think I could do that. Huh.
Okay,
Alrighty.
let's finish up.
Okay.
Let's see one moment. Okay, let's continue. We come to graphs and functions. One moment. All right. When we want to do graphs, we use what is called Cartesian or rectangular coordinate system. It's named after French mathematician René Descartes and consists of two perpendicular number lines, the x-axis, the y-axis, and the x-axis. The horizontal line is called the x-axis. The vertical line is called the y-axis. I'm sorry. Okay. The point where both of the axes intersect is called origin. And the axis divide the plane into four parts or quadrants. So you have this is the y-axis, this is the x-axis. Here you have the first quadrant, second, third, and the fourth. It helps us to plot points and draw lines. For example, if it says find a point 3, 5, the first value, the first number is the value of x, means 3 points in the positive direction. So you come 1, 2, 3 here. And the 5 is the value on the y-axis. It's positive, so you go up 1, 2, 3, 4, 5. That's here is 0.35. This is a 0.60. You go 6 value of x. It has 0. It means that it's not on the y-axis. For this one is -4. It goes 4 points here, and 1. It goes 1 step, 1 unit up in the y-axis. This is the x is 0. It's only on the y-axis, but the y is -5. So you go 5 units down. That's basically how does this Cartesian or the coordinate system works. When you have a relationship between two quantities, sometimes it can be expressed as an equation. Y is equal 4 minus x2. So y is a function of x. Y is a variable, and x is the y. The variable y is a function of x. So for different value of x, you get different value for y. For example, if you take a look at page 374. Page example 4, look at, it says, find each of the following for f of 4 or for f of x equal to 2x plus 3. It means the x, we have a y is a function of x. So it says put different value for x and find out what's the value of your function. Here it tells us f is 4. The problem the problem itself tells us for x is equal to 4. What is fx? 2x plus 3. So you just substitute 4 for x. So you get 11. 2x, 2 times 4 is 8, plus 3 is 11. Or for number C, it says h of minus 5 for h is hr r to the power of 3 minus 2r2 plus 5. It means for value of r equal to minus 5, so find the value of function hr. So for r, you just substitute minus 5. So you get minus 5 to the power of 3 is minus 125, minus 2 times minus 5 to the power of 2 is 25 plus 5. You do the addition and multiplication and addition, you get the number 170. So for the answer is 170 for r equal to minus 5. That function is equal to 170. The graph on equation in two variable is a set of all the points whose coordinate satisfies that equation. And then one method for graphing such equation is point plotting. So let's look at page 372 and 373. For example, example 2, it says if we have graph y equal to 4 minus x to the power of 2. So all you have to do is to give different value for x and then find the value for y. So in the table, you can see that if I give different value for x from minus 3 all the way to plus 3, I plug it into that equation, I get the value of for y. And then I have these pair points. And then I find these pair points on that Cartesian diagram, and I connect them. You see the graph on figure 7.4. So all you have to do is to put different value for x, find a value for y, then you have paired ordered pair. You find those points on the Cartesian plane. You connect them. You get your graph. Okay. When I can tell you this, just beside what you have here, when the power of x is 2, you always get some kind of a curvature. But when the power of x is 1, you always get a straight line. All right. Okay, for example, look at example number 3. It says a toll to a bridge costs $2.50. Commuters who use the bridge frequently have the option of purchasing a monthly discount pass for $21. With the discount pass, the toll is reduced to $1. The monthly cost y of using the bridge x times can be described by the following formula. So this formula is given to us. Y is equal 2.5 times x. That's without the discount. Now, with the discount, is y is you got $21 plus 1x. X is the number of times that you cross the bridge. So then it says, now we want to find out, okay, does it really worth it or at what point does it worth it to purchase this pass? So you have these two equations. you give numbers to x and find a number for y. You have those two tables on page 373. You give different number values to x, you find different values for y for those both equations. The first equation is without the discount. The second equation is with the discount, but you purchase a pass. Then you plot them. You plot these two lines. You notice on figure 7.5, these two lines cross each other at the point 14 and 35. So it tells you that if the bridge is used 14 times a month, the total monthly cost without the discount pass is the same as the total monthly cost with the discount pass. When the point that these two lines cross means equality. So in order for your pass to have value, you got to use that commuter pass more than 14 times. Then you start getting some value for your pass. Otherwise, if you only use it up to 14 point, the value is the same. You follow?
Yes.
Okay. All right. 372. We did this. Again, it talks about graphing a function on page 376. Again, when you have a function, like example 6, it gives you a function, f of x is 2x, and g of x is 2x plus 4. So you give different value to x, and you find ordered pairs for each of these functions. You find them on the Cartesian point, you connect them, and you draw the line. You get that red and blue line on figure 7.9. All right, or let's look at something more interesting. Okay. Like if you go to page 380, like it gives you graph each equation in exercise 21 to 32. Select the integer for x from -3 to 3, inclusive. So in other words, you go from, if you have, that's the function f of x, f of x or y is equal x to power of 2 minus 2. You just put different numbers in each of them, and you get the value of y. And then you connect them together. Basically, that's it. You just have to put values and find a paired points and then connect them. All the equation of the form ax plus by equal to c are a straight line when graph as long as a and b are not both 0. Such equation is called linear equation in two variables. The x-coordinate of a point where the graph intersects x-axis is called the x-intercept. The y-coordinate of the point where the graph intersects the y-axis is called the y-intercept. To locate x-intercept, make y equal to 0, solve it for x. To locate y-intercept, set x equal to 0 and solve it for y. Now, important thing in graphing is slope. A slope basically means rise over run. Changes in y over changes in x. This is basically this formula. Y is equal mx plus b. M is the slope. M is the slope. All right. So, for example, the slope here, run is the change in y, y2 minus y1 over rise over run. over x2 over x1. When the slope is positive, your line goes up, like the red line. When the slope is negative, your line is going down. When you want to find the y-intercept, plot the point containing the y-intercept on the y-axis. That means x is 0, and you want to find the value of b. M is a slope, write m as a fraction, and use rise over run to find the slope. Let's look at an example that makes it more clear instead of all these words. If you go to page 388, okay, look at example 4, page number 388. It says graph the line function 2x plus 5y equals 0 by using slope and y-intercept. So in order to find the slope, I have to bring everything y. I want to have y on one side. I want to change it to that formula. Y is equal mx plus b. Remember, that was the formula for m is the slope. So I add minus 2x to both sides. All the x's goes to the right-hand side. Then I divide both sides by 5. So I get y is equal minus 2x over 5 plus 0 over 5. 0 over 5 is 0. So my answer is y is equal to minus 2, 5, x plus 0. The slope is minus 2, 5. That tells me that line is going downward. That tells me the rise over run, the change in y is 2, the change in x is 5, and that 0 is the y-intercept. So it tells me on that Cartesian point, where x is 0 is that origin, and the run is the change in x, which is 5, and change in y, which is 2. So I get that point minus 2, 5, and I connect that and make a straight line from 5 minus 2 to the origin, and that's the graph. Or look at example number 5. It says graph y minus 4. Where y minus 4 means x is 0. So, or actually it means your y is constant. Your y is always minus 4. So on figure 7.3, you go up. The slope again is y is equal mx plus b. It is negative. So the y-intercept is minus 4. So I go 4 points down. You see that the blue line that goes, and then you draw a straight line. All the points on that blue line, the y is always minus 4. Okay? No matter the value of x. All right? Let me continue. I think I have one. The solution to a system of linear equation can also be found by graphing. When you graph and where they intersect, that's the solution for the two linear equation. Let's look at example on 395. It says solve a linear system by graphing. Example number 2, page 395. You have x plus 2y equal to 2. and x minus 2y is equal to 6. So all you have to do, you find the x-intercept and y-intercept for both of these lines. To find the x-intercept, you make the y is equal to 0. For the first formula, x becomes 2. And to find the y-intercept, you make x equal to 0. It becomes 0 plus 2y equal to 2. And you simplify, y becomes 1. So I got one of my point is 2 and z. For the x-intercept is 2 and 0, and the other one is 0 and 1. I find these 2 points on that graph, on that Cartesian plane. I connect them, and I draw that blue line. Okay. The second one is x minus 2y equal to 6. I do the same thing. Find the x-intercept, find the y-intercept, find those points on the Cartesian plane, connect them, and then you draw the line. Where they intersect, the intersection of these two lines, which is the point 4 minus 1, is the answer to that equation. 4 minus 1. In other words, for x equal to 4 and y equal to minus 1, these two equations hold true. That's basically the same. So if necessary, rewrite both equations in the form of ax plus by, then same thing we just did. You find the x-intercept, you find the y-intercept, you draw the both lines. When they cross each other, that's the solution. And you can back substitute your value and check your answer. Like, let's look at page 399. Okay, it gives you two formula, 3x plus 2y 48 and 9x minus 8y is 24. So you want to multiply the first one, multiply the first one by minus 3. So because you want to add them together. So you get minus 9x minus 6x equal to 144. You don't need to make any change in the second one. You add them together, you get minus 14y equal 168. Y is 12. When you substitute 12 into the equation, you get x is equal to 8. So that's your answer, 8 and 12. So you can solve the answer by graphing, or you can solve it by using the addition method. When you have inequalities, replace the inequality symbol with equal sign. And again, you just have to watch if you multiply by a negative or divide by a negative, you have to reverse the sign. But let's do an example that's much more easier. For example, example number 1 on page 409 says graph 3x minus 5y greater than or equal to 15. So you find, first you find the x-intercept. Again, you set y equal to 0. Then you set the y-intercept, you make x equal to 0. You find x and y. Then you put that, you have two paired points. You find them on the Cartesian plane. You connect them. You got that solid blue line, so which includes, in other words, for any number on that line, that inequality holds true. Okay. Let me see. Let's look at example number 2 on page 410. Says graph a linear inequality in two variable, y greater than minus 2 over 3x. So the slope is, the formula, remember, is y is equal mx plus b. So the slope is minus 2/3, and it's negative, so it tells me it's going down. So I go down on the changing y, I go 2 points down, and then I go 3 points to the right. So that's a rise over run, minus 2/3. And the y-intercept is 0, meaning it passed through the origin. The y, it's only at that point that y is equal to 0. So you can connect these 2 points, and it tells you that for all the y which is greater than or equal to 2/3 x, so you choose a test point, choose point 1.1. If you put 1.1 in that equation, you see that for y and for x, you see that yes, 1 is greater than minus 2/3. So that's why it has shaded green all the places above that line. And notice the line is not solid. It's segment by segment because it's not equal. Okay. And another thing that you need to remember, okay, is exponential function y is equal to b to power of x. B is a positive constant other than 1, and x is any real number. Let's look at example 423. If that's a function, it says for function f of x or y equal to power of x, you give different value to x, you give different, and you find the value of f of x, and then you put them in a Cartesian plane, connect them, and you draw your line. And again, remember, whenever you have more power of 2, that means it's going to be curvature. We have something called logarithmic function. The function f of x is equal log base b of x is a logarithmic function with base b. Log b, y equal to log b of x is the same as, remember that, that's very important. It will come on the test. You got to memorize that y equal log b of x is the same as b to power of y equal to x. Equation y log b of x and b to power yx are different way of saying the same thing. The first one is logarithmic, the second one is exponential. If we go to page 427, again, in order, example number 4, it tells you graph y log 2 of x. Well, log 2 of base, 2 of x, is same as, it means 2 to power of y is equal to x. So you give different value to y, and you find the value of x. And then you got these ordered pair points, you draw your line. But you just have to remember that formula, that y log b of x is the same as b to power of y equal to x. And this kind of graphing, when you have ax to power of 2 plus bx plus c, is called parabolic graph. And you use it by doing the following steps. First, find out this parabola opens upward or downward. I will show you a video that explains that. Then find the vertex, the x-coordinate, The y-coordinate is found by substituting the x-coordinate into the parabola equation by the x-intercept and replacing the y, or solve the resulting quadratic equation, find the y-intercept and plot the intercept and vertex, connect the point. I think this video explains it very clearly, makes it much more easier. Let's watch this.
We're asked to graph the following equation. Y equals 5x squared minus 20x plus 15. So let me get my little scratch pad out. So it's y is equal to 5x squared minus 20x plus 15. Now there's many ways to graph this. You can just take 3 values for x and figure out what the corresponding values for y are, and just graph those 3 points. And 3 points actually will determine a parabola. But I want to do something a little bit more interesting. I want to find the places. So if we imagine our axes, this is my x-axis, that's my y-axis, and this is our curve. So the parabola might look something like this. I want to first figure out, where does this parabola intersect the x-axis? And as we've already seen, intersecting the x-axis is the same thing as saying, when does this parabola when does y equal 0 for this parabola, or not?
Okay, so you see, the first thing he does, he finds the x-intercept. And x-intercept means where this graph, this parabola, crosses the x and y is equal to 0. So he's going to set y equal to 0 and solve for x.
Another way of saying it, when does this 5x squared minus 20x plus 15, when does this equal 0? So I want to figure out those points, and then I also want to figure out the point exactly in between, which is the vertex. And if I can graph those 3 points, then I should be all set with graphing this parabola. So as I just said, we're going to try to solve the equation 5x squared minus 20x plus 15 is equal to 0. Now the first thing I like to do whenever I see a coefficient out here on the x squared term that's not a 1 is to see if I can divide everything by that term to try to simplify this a little bit, and maybe this will get us into a factorable form. And it does look like every term here is divisible by 5, so I will divide by 5. So I'll divide both sides of this equation by 5, and so that will give me, these cancel out, and I am left with x squared minus 20 over 5 is 4x plus 15 over 5 is 3 is equal to 0 over 5 is just 0. And now we can attempt to factor this left-hand side. And we say, are there two numbers whose product is positive 3? The fact that their product is positive tells you that they both must be positive, and whose sum is negative 4, which tells you, well, they both must be negative if we're getting a negative sum here. And the one that probably jumps out of your mind, and you might want to review the videos on factoring quadratics if this is not so fresh, is negative 3 and negative 1 seem to work. Negative 3 times negative 1. Negative 3 times negative 1 is 3. Negative 3 plus negative 1 is negative 4. So this will factor out as x minus 3 times x minus 1. And on the right-hand side, we still have that being equal to 0. And now we can think about what x's will make this expression 0. And if they make this expression 0, well, they're going to make this expression 0, which is going to make this expression equal to 0. And so this will be true if either one of these is 0. So x minus 3 is equal to 0, or x minus 1 is equal to 0. This is true, and you can add 3 to both sides of this. This is true when x is equal to 3. This is true when x is equal to 1. So we were able to figure out these 2 points right over here. This is x is equal to 1. This is x is equal to 3. So this is the point 1, comma 0. This is the point 3, comma 0. And so the last one I want to figure out is this point right over here, the vertex. Now the vertex always sits exactly smack dab between the roots. When you do have roots, sometimes you might not intersect the x-axis. So we already know what its x-coordinate is going to be. It's going to be 2. And now we just have to substitute back in to figure out its y-coordinate. When x equals 2, y is going to be equal to 5 times 2 squared minus 20 times 2 plus 15, which is equal to, let's see, this is equal to 2 squared is 4. This is 20 minus 40 plus 15. So this is going to be negative 20 plus 15, which is equal to negative 5. So this is a point 2 comma negative 5. And so now we can go back to the exercise and actually plot these 3 points. 1 comma 0, 2 comma negative 5, 3 comma 0. So let's do that. So first I'll do the vertex at 2 comma negative 5, which is right there. And now we also know one of the times it intersects the x-axis is at 1 comma 0, and the other time is at 3 comma 0. And now we can check our answer, and we got it right.
Okay. I hope this helps. All right. Sorry.
We're at
Oh, okay, that's it. Any questions? I know there were lots of material, so please review them. Don't worry, I'm not going to ask you difficult questions, but be familiar with this concept. Are you guys okay?
Yeah.
Okay.
Yeah.
All right. Okay. Ruben, are you okay?
Yeah, I'm good. Just probably have to review a little bit, but I'm good. All in all, I'm good. Thank you.
All right. Okay. Then I wish you a blessed Thanksgiving Day for you and your family. And let's have a prayer. Ruben, can I ask you to pray and close our time together?
Sure. Heavenly Father, we thank you, Lord, for this time. Thank you for my classmates, my professor, Lord, for the seminary, for just the opportunity to learn, Lord, this math, Lord. I just pray that you help us in our studies this week. I pray that you bless everybody's Thanksgiving as they meet with their families. Give us the direction, Lord. I know we're going to be dealing with family members and friends, possibly, Lord, that don't know about you, Father. May you give us the words and may your Holy Spirit guide us in our conversations as we get together for Thanksgiving, Lord. May we glorify you in all things that we do this week, Lord. And I just pray that as we come and go, whether we travel far or near, Lord, may you protect us as we go on our travels, Lord, and just be with us throughout the week, Father. And I just thank you for everything that you've blessed us with Lord, because we're thankful, God, because
Thank
you
you.
provide everything. And we just thank you, Lord, and we just pray this in Jesus' name. Amen.
Amen.
Thank you, guys. And
Yes.
see you next week.
We'll see you guys. Thank you. God
Have a
bless you.
good one.
Take care.
Bless you.
Take care. Bye-bye.